Hello everyone. I welcome all the biologists, researchers, distinguished guests, and fellow enthusiasts of computational drug designing. I am truly delighted to welcome you today for the today's webinar. Sorry, not webinar. It will be a workshop on design sprints. This will be a rapid CAD journey. I am Kashmila, and I have the honor of being your host for this exciting and knowledge-packed event. Before we dive into the depths of computational drug designing, allow me to set the stage for providing a brief overview of what we have in store for you today. Our journey begins with an essential foundation of introduction to CAD and its paramount importance in modern drug discovery. We will explore how CAD accelerates the drug discovery process, saving both time and resources. Following this, we will delve into the world of data, various elements in CAD. In the realm of ligand based drug designing, we will uncover how the interactions between small molecules, ligands, and target proteins guide the drug design process. On the other hand, structural based drug designing takes a step closer to understanding the atomic level details of drug target interactions. Throughout our webinar today, we encourage active participation from all our audience. Feel free to ask questions, share your thoughts, and engage with our speakers. After all, the exchange of ideas and knowledge is what makes these events truly enriching. So fasten your seatbelts, grab your notepads, and get ready for a thrilling journey through the world of computational drug design. Our esteemed speakers are eager to share their expertise. By the end of this webinar, you will have a clearer understanding of how CAD is revolutionizing drug discovery. Also, I request everyone to please make a note that you will be eligible for the participation certificates only if you have marked the attendance that via link that we will be sharing in the last hour of this workshop. So, without any further ado, let's embark on this exciting adventure of knowledge and innovation. Thank you for joining us, and let's make this webinar an insightful and unforgettable experience. I request Dr. Jyoti ma'am to please take over the platform.
Thank you, Kashmira.
Most
Hello,
welcome, ma'am.
everyone. Okay, now I'll share my screen. Kashmira, can you just make sure if my screen is visible?
Yes, ma'am, it's visible.
Okay, thank you. Good evening, everyone. So myself, Dr. Jyoti, and a brief introduction about myself is like I have been in the field of bioinformatics since my graduation time. So it's been almost 16 years I'm doing bioinformatics. And in my PhD and my industrial exposure, I have worked on CAD things. So here I will be discussing brief about CAD. Of course, CAD is not something that can be done in 1 or 2 hours. It is a theory that we will try to understand. I will try my best to make sure that you, at the end of this webinar, at the end of this session, you will be able to understand how CAD is useful for the drug designing in nowadays. Okay. Okay, fine. So let's start with the definition of CAD. Most of you must be knowing what the CAD is, as the name is, defining itself. That is the computer-aided drug design. That means we will be designing the drug with the help of computational algorithms or methods. Okay. So when it is about the drug designing is the multi-step process. It is not simply just take any compound and launch it as a drug. It is not like that. It is a multi-step process, and it is a very time-taking process. In the previous time, what happened? Like if you have to design a drug, it took at least minimum 15 to 20 years to launch a single drug. Okay. And in the launching of that drug, there are so many things that we have to go through. Okay, so it start with the screening. Screening means whatever the compounds you want to screen against the particular disease, as it is a complete different method. It start with the disease, one particular disease. Definitely, if we have to design the drug, we have to understand for which disease we are designing it. Now the disease is clear in your mind. For example, let's take an example of diabetes. I want to design the drug for diabetes, but diabetes is not a disease that is caused by one single reason. There are so many reasons that due to which the diabetes, the so many reasons is in your human body. There are many things, there are many genes or proteins which are responsible in this disease, particular disease. Okay, so you can select on that basis which particular target, which this target ligand terms we will discuss in detail. Just try to understand how we dive into the cadd. Basically, when we select the disease, we have to make sure what we have to work on. And the very thing we have to work on is the reason of the disease. What is the cause of the disease? What is there in the body which is responsible for the pathogenicity of the disease? If that thing is clear, then 50% things are done. Okay, if the 50% things are done, we have to further think about what is the possible compound that can be screened against this particular target. What are the possible things or what are the possible changes we can do in the compound so that it become a perfect fit for this particular target. Okay, further we have to evaluate whether it is compatible for the target or not. So this screening, optimizing and evaluating, these are the processes, okay, where we are using, where we are checking the compound against the target. Now here, what is the target? Something that is responsible for the disease, okay, responsible for the cause, responsible for the pathogenicity, etc., whatever, anything. And this target could be gene, protein, RNA, anything. It could be anything. Okay, now, when we define the cadd, it is the combination of the computational methods and resources. Here, when we are talking about the methods and resources, so that means some tools and databases, software, so many things will be there. All computational things, okay? When these computational things will be used to design the drug for the new therapeutic solution, for the disease we have to work on. Okay, that is what your cadd is.